Hey everybody, welcome back. This is going to be video number 3 in our FreeBSD series. It's great to have you. So if you notice here, I've kind of got us already all set up on the screen. I've already logged in. I am in the system right now. We can actually do uname switch R, uname switch A. You'll see that we're in FreeBSD right now. I'm not logged in inside of the official system, and something that I'm going to do just to kind of prove A, how useful this is, and B, how much more convenient this is. Instead of running the virtual machine here down in the corner, what we're going to do is we're just going to close it, and you're going to notice that everything keeps running. So in addition to that, we're going to do a little bit of quality of life improvement here. So we're already running fish, and if you have been following along through the previous videos, you know that I like fish as a shell. And then in addition to that, we've already installed that. So the first thing that we're going to do is we're going to type sudo package install curl, and then I'm going to hit space, and I'm going to type git. And we're going to see this begin the process of doing some downloading here. And we have a whole bunch of stuff that is now being downloaded. We can see CA root. That's going to assist curl with being able to deal with HTTPS. We've got curl, we've got git, and we've got a whole bunch of other supporting items. I'm going to proceed with this action. I'm going to say yes. And the reason why is we're going to do two things today. The first thing that we're going to do is we're going to do, like I said, quality of life improvements. So we're going to install OMF or Oh My Fish, which requires curl as well as going to require git. And then when we're done with that, we're going to start looking at hardware as well as at the kernel itself within FreeBSD. And I want to show you this because there may come a day that you decide that you want to build your own kernel from source. And I want to show you just how easy that is whenever you're dealing with something like FreeBSD. So this installation is going to just kind of chug along here, and then it's done. So the first thing that I'm going to do is on my local system, I'm going to open Firefox. And now that that has loaded, I'm going to look for install OMF fish. That's going to take me to their GitHub. And then I can come down here. I'm going to grab that, and I'm going to dump it right on in. And at that point, we can use that browser. So you'll see completely installed OMF. It was very, very fast. The next thing that I'm going to do is I'm going to install a theme template specifically for my shell. So I'm going to type in OMF install SCORPHISH, Scorpfish. I really like Scorpfish. I use it all the time. And then I'm going to hit clear. And you'll see there's a little bit of change here. It mostly looks the same, but you're going to see some symbols here relative to a font, and then you're going to see how long did the previous command take to execute. And then when we get to the point where we actually pull down some stuff from Git, you're going to be able to see some quality of life improvements that happen with the shell that allow you to identify what's going on within the system related to when you're inside of an actual Git repository. So the next thing that we're going to do is I'm going to try to cd into a directory called user source, and I'm going to hit ls, and you're going to see that that's empty. That's totally okay for now. I'm going to go back to my home directory, pwd, and I'm back in the home directory. So your kernel does a lot of work. The kernel for the operating system handles hardware. It handles interrupts. It handles security processes. It's going to handle a ton of items related to your system. So the first item that we're going to want to look at is going to be hardware. So if I type in DMESG, so that's Delta, Mike, Echo, Sierra, Golf, and then I hit enter, I'm going to fill up my screen with a whole bunch of text here. And I can scroll up and scroll up and scroll up, and eventually we get here. And what we're going to see is everything identified by the operating system in terms of what does it have access to. And the first item of interest is going to be right here, because this is our CPU. This is everything related to our CPU. Actually, I didn't make this large enough. Let's go all the way down here. So this is our CPU. So I have an AMD Ryzen Threadripper 1920X. It's a 12-core processor. You can see how many megahertz, 3,493.47 megahertz. It's a K8 class CPU. It's authentic AMD. And then we can see family and ID, model, stepping, and then it starts listing features. All the different stuff that this processor can do is identified here within dmessage. The next thing that we'll see is Hypervisor. So this is important. And it's kind of outside the scope of what we're doing here, but understanding that your system can identify that, hey, there's a hypervisor here, and our origin is KVM. Well, in the event that the day comes that you decide maybe you're going to do a little bit of review or study on a topic like malware, there are methods by which malware can actually identify that it is inside of a hypervisor in a inside of an operating system that's being run virtually, and then it won't do an attack. And the idea there is they don't want you to be able to study that malware or that attack vector. And so what it'll do is it'll look at the system hardware, and then it'll say, hey, this is kind of looking like I'm inside of a virtual machine. To be on the safe side, I'm not going to make any outside connections, so that the person, security researcher, or whoever it is that's decided to take a look at that malware strain isn't going to be able to get very much information out of the system. Again, kind of outside of the scope of what we're doing, but it's just something to keep in mind. You can see my real memory and available memory. I gave this system approximately 4,256 megabytes of memory, and if you remember, on my box, I have 64 gigs of RAM. I'm only giving this thing 4,256. We can keep going. We can see multiprocessor system detected. It knows that it has 4 CPUs, which I did give this system 4 CPUs. Keep on going. It will see drivers. So Mellanox Ethernet driver from December 2020. That is loaded from the MLX5EN driver. And you can actually, we'll come back to that in just a second. I don't want to go too far because we're going to go into something called boot kernel, and we're going to look at some of the modules in there, and we'll see if we can actually find, and I'll just set this off to the side real quick, the MLX5EN driver. Continuing, you can see ACPI, which is all related to power, so we have a power button, or at least it identifies that there is a power button. Remember, this isn't a virtual machine. So some of the stuff that is being recognized is virtualized technology, but for all intents and purposes, the system doesn't see it that way. It just sees it as, hey, I'm inside of a computer, and this is what is available to me. We see USB. Keep going. More power stuff. ACPI is going to be your power. You can see PSM0. That's a PS2 mouse, and it's on interrupt Q12, IRQ12. Keep on going. What else do we see? Hubs, some CDs. The system does believe that it has a removable CD-ROM drive. I can actually mount an image inside of my VirtualBox system, Virt Manager. If I go into Virt Manager and I mount that CD-ROM, then FreeBSD would see it just as if I had taken an actual physical CD and inserted it into the system. And then it goes further down, and we see some other items like security policies that have been loaded and so on and so forth. So if I go to /boot/kernel, WD, see that I'm there, hit LS or Lima Sierra. We can see all of these modules, these KO files that have been loaded. So there's a whole bunch of stuff here. So the first thing I'm going to do is I'm going to type ls pipe rep, and then we're going to look for MLX5EN. I'm going to hit enter, and there it is. That's the module. So MLX5EN was the module that we were just talking about. And if I type vim MLX, you'll see I don't have vim in vim, sorry, MLX5EN. And then we can open that, and you'll see that this is a file that has been compiled. So this is an actual compiled file. And you can just see it looks like garbage is in here, but this is your driver for running your Ethernet right here. And we're not going to glean a lot of information from this. There's just no way, right? Like, it's just kind of garbage. But the fact of the matter is now we know for the Ethernet device to run, it needs MLX5EN.ko to be loaded, and that's just one of the items that gets loaded. Now, on a default installation of FreeBSD, there's a ton of stuff that's going to get loaded. I say a ton of stuff, it's relative, right? It really and truly is. It's relative. Do you need everything here for your system to run? Probably not. And to be honest with you, does it really affect anything? No. Some people will tell you that one of the first things that you should do under FreeBSD is to go in and build a custom kernel that only supports your hardware. And that by taking those actions, you make your system boot faster and increase performance and so on and so forth. The amount of time that you as a new user would spend building a brand new kernel specifically for your hardware would probably far outweigh any of the benefits related to saving time. Okay? The benefit of building a kernel yourself or even creating a kernel, those benefits are mostly going to be educational. And then in addition to that, if you if you do decide that you want to go out and you want to be one of the people who contributes to the FreeBSD kernel, this is the kind of information that you're going to need to know. So this is high level stuff. This is understanding, hey, how do I find out what hardware is connected to my system? What's available to me? Where are the drivers loaded from? What are these modules? Another thing that we can do is Pci Conf. So that's going to be Papa, Charlie, India, Charlie, Oscar, November, Foxtrot. And then we're going to type dash or switch and then LV. So that's Lima, Victor. Hit enter. And now everything's kind of broken out for you. It's a little bit easier to read. We can see here we have a bridge, host, PCI. So this is our PCI, ISAB, ATA PCI, continuing VGA, PCI. So this is where it sees it as a vendor, Red Hat Inc. device, QXL Para virtual graphics card. Nice information to have in the event that you're inside of a system and you're trying to figure out what is available to you. And then, of course, typing something like PCI Conf switch LV would be another method by which we could see that, hey, we're probably inside of a system that's being virtualized on account of the fact that we can see a QXL Para virtual graphics card. So now that's going to tell me a little bit of information about where I'm actually located in terms of the hardware itself, right? So just fun tricks, right? Good information, just quick ways of handling this. So I'm going to hit clear. I'm going to type ls, and then I'm going to go back to home, clear one more time. Now, here's the next thing that I'm going to do. I'm going to go to user source, and I'm going to get clone into here, and this may fail out this first time. There, user source. Permission denied. Let's try sudo. And this may take a moment, because remember, what we're trying to do is pull down the entire FreeBSD source. And that's going to take a while for that thing to communicate. Yeah, you can see here. It's going to start that process. Ooh. That actually may be too big. I don't think we're going to have enough hard drive space for this, but we can give it a shot. Just very quickly log in. -h. That's filling up user source. You can actually see that. One of the things that we can do is we can do a watch on df switch h. Oh, it won't allow me to watch df switch h. Okay, interesting. So hopefully that's not going to fill up too much. I think we're going to be okay. I think we will. That's going to be a few gigabytes. We're about halfway done. We're almost halfway done, and we're at 741 megs. So we're going to let that run for just a little bit. And in the meantime, while that is running, we will talk about some other items. So ls switch lah. Here you can see you have a .config folder. So we'll cd.config, type ls, cd fish, ls, and then we can go in here to functions. And this is where you would create functions that would work like aliases or other stuff that you can do within Fish. Fish is highly programmable. And so if you want to make a lot of changes to Fish, and I'm just talking about this right now while we're waiting for the Git source code to download. But as soon as that's done, we'll pivot right back to Git. But in the meantime, one of the really cool things about Fish is you can create your own functions, and those functions can do pretty much anything. So I have a function called music rip, and what music rip does is it will allow me to hand it over a YouTube URL, and then it will pull all of the audio from that YouTube video. It'll just go in and use YouTube download, YouTube DL, downloads a copy of the video down, and then it automatically strips out the audio and turns it into an MP3 file for me. I really, really like Fish. And at some point, we'll do a deep dive on Fish, and we'll talk more about that as well. I'm planning on making lots of informational videos for use as we work through this. And so you can see we've already completed our download up here. This is going to take just a little bit of more time because it's got to pull even more additional information. And then once that's done, and mind you, we go to HTOP, we're using all four of those CPUs. All four of the CPUs are pretty much maxed out. We're going to get 100% out of them the entire time that it's working on stuff. So nothing's going to waste is what I would say here. You're not going to end up in a situation where if you put, let's say, 8 CPUs inside of your FreeBSD machine, none of that's going to go to waste. You'll be able to use all of those cores. Those deltas are done. This thing will finish updating the files, and then we will have access to our stuff again. And just very quickly, this is a full screen HTOP. If you're running Linux right now, run HTOP and take a look at what you see. And I bet your system is running a ton of stuff in comparison to just a handful of lines under a FreeBSD machine that actually runs straight out of the factory. So there we go. We have it. I'm going to exit out of this so that we have the ability to come here, hit ls, and you're going to see now we have all of the kernel code right here. So the first thing that I'm going to want to do is I'm going to want to look at this make file. And this make file is relatively large. There's 793 lines here. Another way that we could do this is we could cat that make file, and then we can pipe it into wc-l, and then we get that 793. So now we know there's 793 lines related to this make file. And if we come in here, it will start to tell you everything that you can do. Some of the commands will be make universe, and it will build everything, and it will build all kernels on all architectures. At some point, using my Threadripper, I would actually like to do that with all of the resources pointed towards that. I would love to see how long that takes and what that requires, but we're not going to do that today. That's not going to happen, so don't worry about it. There is tons of instructions in here, lots of comments, a lot of comments. So you can come in here and you can see if you wanted to upgrade your sources, you would cd to user source, you would make build world, you would make build world kernel conf, and then you would name it. So default is generic. Make install kernel conf equals generic. And then of course you can combine steps 3 and 4 by using the kernel target if you wanted to. And then you would reboot the system, merge master, make install world, merge master, make delete world, reboot, make delete old libs. So from steps 1 to 11, that's everything that you need to do if you were going to use the default kernel of generic. So where does that generic come from? What are they talking about there? Well, if we try to do something like invim, generic, we're going to say, hey, there's no generic here. How do we find that? We can do find period dash type f dash name generic, hit enter. And now we can see there's actually a generic file for each one of the kernel types. So if you're going to build for PowerPC, ARM64, AMD64, i386, ARM, or RISC-V, then you could actually go in there and you could take a look at that generic file. Now, one of the things to keep in mind is don't ever edit that generic file because you want to keep that file the same. That's the generic file. Do not edit that. Make a copy of it. And then whatever you name it, that's what you would reference. So if you wanted to create Aaron J custom, you would do that all capital letters in the exact same folder as that generic. And I'll actually show you how this is done. So we're going to go into AMD64, conf, ls, we see generic in here. We can cat generic, pipe it to what? WC switch L. There's 400 lines. So let's find out what's inside of it. And now we can see everything is listed here. CPUs, ident, make options, different options that are here. So if you want to enable preemption for kernel thread preemption, you can turn that on or turn it off. Networking, you can turn that on or off. There's a handful of other things here, disk quotas, making sure that items are compatible with different systems, EFI runtime service support. And what I would recommend to somebody who is interested in eventually going out and working on kernels is take a little bit of time to sit down here and say, what are trusted BSD Mac frameworks? Well, that's on this line right here. I'll highlight it. Right? Trusted BSD Mac frameworks. What is that? Look it up. Find out. If you want Kernel debugging support, you can turn that on or off. This says always need this. So something to keep in mind. If you're going to build a kernel, probably don't want to turn that stuff off. Right here it says turn off in stable branch. So if you're going to be running the stable branch, you don't need all of these items right here. There's kernel sanitizers, kernel dump features, CPU frequency control, so on and so forth. Everything that your system could potentially support has been built in here, from sound to Hyper-V drivers and enhancement support and so on and so forth, all in here. You'll see KVM para-virtualization clock driver. I have to have that because I'm running the system inside of KVM. So we're going to close that for now. If I wanted to make my own, I could do something like sudo copy generic, and then I could rename generic to kernel dash Aaron J. sudo kernel dash Aaron J. And this right here is what I would actually edit. I would come in here and I would start the process of editing this, and then as I edit this file, I would update everything. Okay? So I'm going to exit out of that. Sudo rm kernel underscore Aaron J. Gonna pull that out. Clear. And then we can kind of back out through here and we can see, well, there's a lot of interesting stuff that's included here. Linux support. That's interesting, right? Why? Well, we may get to that at some point, but we're going to talk about some of the tools that are made available to you as a FreeBSD user that allows you to run certain Linux-based applications in a way that is sometimes very close to native. Okay? I'm not going to say it's perfect, but certain Linux-based applications can potentially run under FreeBSD. And back just a little bit more. So user source, we're in here. I think that covers everything that I want to talk about here in terms of the kernel. If we were going to build the kernel ourselves, it would take a significant amount of time to build a kernel, even using 4 CPU cores. There's a reason why Linus Torvalds runs Threadripper, right? If you're going to do a lot of kernel development work and you're going to have to rebuild the kernel over and over and over again, you're going to want a system that can handle that, and that's going to require a lot of processing power. And in addition to that, you're going to want a system that does a lot of multi-threading. So regardless of how fast your system is on single core, when it comes to working on something like the kernel, it behooves you to have more cores. The more cores, the better. So that said, that's a very gentle introduction to a little bit of quality of life improvements right there at the beginning of the video. And then, hey, how do we pull down a copy of the kernel? You git clone it from freebsd.org. You dump it into user source, and then from there you can start exploring and playing with it, and it gives you right there within that make file all of the instructions that you need for being able to begin that process of building your own kernel. Even if you just wanted to build a generic kernel, which is effectively a copy of your current kernel, you could do so and then implement that just to prove to yourself that you were able to do it if you wanted to. You know, I'm actually gonna, let's see. Let's do this. So I'm gonna go in here and let's see how long this actually takes. We're gonna give it a shot. All right, so we're inside of user source. And then from there, we're gonna do make build world. And this may actually require me to do a sudo. It did. So we're gonna start that process of bootstrapping. And as this goes, I'll just talk to you a little bit about the kernel, and one of the nice things is I have the FreeBSD book. So I'm just going to talk to you out of the FreeBSD book while we allow this to build. And if this just keeps going and going, which it may just, then at some point we will call it. So if you're going to understand the FreeBSD kernel, some of the items that you're going to want to understand are your kernel is a service provider. So all of your user processes, they're going to go through the kernel. Uh, Usually, that access of these systems of these services is going to be through system calls. But some services, like your process scheduling and memory management, those are going to be implemented as processes that will execute in kernel mode or as routines that execute periodically within the kernel. So what does that mean for you? That's going to mean everything between you and the system at some point is going to travel through the kernel in either kernel mode or otherwise. And in addition to that, um, it's probably the most important part of your entire computer. I think I would that may be a statement that people might argue with me about. I'm thinking about that. It might be uh, it might be. That might be a statement that people don't like, but I think I would stand behind that. I think I would state that the kernel is the most important piece of what makes your operating. Regardless of everything else technology-wise, without that kernel, obviously nothing else is going to work. And the kernel itself is going to set the stage for the rest of the design of the entire operating system and all behaviors. Yeah, I'm fairly certain with 4 cores this is going to take hours. So with that said, I'm going to shut this one down. This video is a little bit shorter, so only at probably about 30 something minutes, but you can go through that make file, you can head on down in there, and you can actually build your own kernel directly within there. At some point, we may come back and revisit this and just build a kernel, and then I'll do some of that movie magic where we just speed things up just to demonstrate exactly how all of this works. But in the meantime, thanks for joining me. I hope you enjoyed this. It's a very gentle introduction. Like I said, this isn't super hardcore, and I do encourage you, if you're interested in these topics, to kind of look further on into this. But with that said, I will see you all later.